Let's find the approximate zeros of a function by using a graphing calculator. Now I'll go over two different ways to use a graphing calculator to find the approximate zeros of a function, but in real life you'll probably just use one of these ways. Now if you just want to find the approximate zeros of a function, you're done here. However, if you want to check your work, then let's find the approximations of the zeros we found using algebra. We can then compare the approximations from the first two bullets, so the approximations from using a graphing calculator and the approximations from algebra, and to see if the answer we found algebraically is correct or incorrect.
Suppose that you want to find the zeros of a function. Well, at least the approximate zeros of a function. So you can press y equals and enter in the function. Then you can press second and press a button that says trace, with a blue text above it saying calc. Then choose option 2. Now the calculator graphs the function. If you don't see the zero that you want to find shown, then you can change the window and press second calc again. Now I ask you for the left bound. So move the pointer left of the zero that you want to find, and then press enter. It asks you for the right bound. So move the pointer right of the zero that you want to find, and press enter. It asks for a guess, but you can just enter instead of guessing where the zero is. And then it gives you the approximate x value for the zero. Now I should probably point out that some of the latter digits of the x value may or may not be accurate based on calculator error. Also note that the y value mentioned isn't exactly 0. This is due to calculator error. To find the other zero of the function, use the same procedure. Press second calc, choose option 2, and then enter in the left bound and the right bound. Press again for guess, just enter in for guess, and the calculator gives you an approximation for the x value of the zero. Let's now talk about another way to use your graphing calculator to find the zeros of a function. Press y equals. Enter in your function. Press second, and press the button that says graph, and have the blue text above it saying table. Now y1 is 0 somewhere between here and here, because it's positive here and negative here. So y1 is 0 somewhere between when x is negative 3 and x is negative 2. So go to when x is negative 3 and press plus. The plus is a way to see this delta table, which decides the change in x for each preceding entry in the table. Enter in 1/10. Press enter. Now somewhere between here and here, y1 is 0 because here is positive and here is negative. So y1 is 0 somewhere between when x is negative 2.5 and x is negative 2.4. So go to when x is negative 2.5 and press plus. Enter in 100th and press enter. Continue doing this pattern until you have the desired precision. Somewhere between this y value and this y value, y is 0. So that means that the corresponding x to when y is 0 is somewhere between this x value and this x value. Both of them round to negative 2.47480096. And that is my desired precision, and I have an approximate answer. Then do the same thing for the other 0. First though, you'll need to reset the table. So press second and press a button that says window and has a blue text above it saying table set. Have the table start be negative 3 and the delta table be 1. And then you can go to second table again. And do the same thing for the other 0. So between this y value and this y value, y has to be 0 somewhere. So the corresponding x for when y is 0 has to be between 0 and 1. So that means between this y value and this y value, y has to be 0 somewhere between there and there. And so somewhere between this x value and this x value, that is a corresponding x value for when y is equal to 0. And so both of these round to 0.80814, and that is my desired precision. And here's my approximate answer for this 0.
So the zeros we found by using algebra were -5 plus or minus the square root of 97 all over 6. There are 2 zeros here because of the plus or minus, so let's find the approximation of each root. Let's start with the plus 1. Type in the beginning parentheses so that the whole expression of -5 plus the square root of 97 would be in parentheses before dividing by 6. Then type in -5 plus the square root of 97. Type in the ending parentheses. Then divide the whole by 6. For the other zero, type in the beginning parentheses so that the whole expression -5 minus the square root of 97 would be in parentheses before dividing by 6. Then type in -5 minus the square root of 97. Type in the ending parentheses. Then divide the whole by 6. Let's find out if the approximations we found from directly typing in the zeros that we found by using algebra match up with approximations we found from second calc and from second table. First, let's talk about the negative roots. Will this match with the answer we found in second calc? Well, here is the answer we found from second calc, and as you can see, both of these are very, very similar, and so it's safe to conclude that the answer we found from algebra is indeed correct. We could also compare it with the table, and yet again we find out that the approximations are very, very similar. Let's now check the positive root. Will the approximation for the positive root that we found by using algebra also be very similar to the approximations we found by using the graphing calculator? Well, here's the one we found by using second calc, and as you can see, these approximations are very, very similar. We could also compare it with second table, and we find out that the approximations are very, very similar. Here's a link to a playlist in which this video is a part of. It includes other similar videos about how to check your work using graphing calculator, such as how to check your work for a system of equations.